We talked about trapezoids last semester. And what's the difference between a trapezoid and a parallelogram? One kind of big difference, right? Perfect. That is a perfect explanation. Very good. Shane said that parallelograms have two parallel sides and trapezoids only have one set of parallel sides. Okay, so that is what we're going to do to show that something is a trapezoid. We need to show that two sides are parallel and the other two are not. Okay, what do we know about parallel lines and their slope? What do we know about parallel lines and their slope? Slopes are what? Are they? The same. So if we can show that two sets of opposite sides have the same slope and two sets don't have the same slope, then we know whether or not we have a trapezoid. Okay, so let's plot these points. We'll plot 1, 5, 4, 7, 7, 3, and 1, negative 1. So, pick any side to start with. It does not matter. We can do KA, AT, ET, EK. Does not matter. What side do we want to start with? Pick any one. KE? Right. So we're going to find the slope of KE. Okay. Oh, count up. How far do we go up? 6. How far did we go over? 0. What do we call this slope when 0's in the bottom? Undefined. Undefined. Right. Then what you have to do is go to the side directly across from KE. What side is directly across from KE? AT. Find the slope of AT. Just count up and over. How far do we go up? 3. It's hard to tell. That's great. How far do we go over? 3. Well, we went to the left, so it is negative. And that's a different answer.
I'm pretty sure it's 4.
That's why I'm on again. Okay. 4. Yep, I did 4. Move that up. There we go. Yep. So it's 4, and then we go over 1, 2, 3. So we went up 4, left 3. That can't reduce. So are these slopes the same? No. And that's okay. That doesn't mean, oh, stop, it can't be a trapezoid. Because we want two slopes that aren't the same. Right? We then have to go find the slopes of the other two sides. And we want those slopes to be the same because that means it's a trapezoid. Okay? So then pick another side we haven't found the slope of yet. Okay? Count up and over. How far do we go up? 2. How far do we go over? 3. Alright? Then find the slope of that last side, ET. Count. How far do we go down? 4. We went down 4 though, so it's going to be negative. How far do we go over? 6. But we went left, so it's going to be negative. What must we always do with fractions? Always simplify. So you might be thinking these slopes are the same, but when we simplify them, what does negative 4 over negative 6 simplify down to? 2/3. Right? Are those slopes the same? Yeah. So is this a trapezoid? Yeah. We have two sides that have the same slope, which means these two sides are parallel. And then the other two sides, which we call the legs, do not have the same slope, which means they're not parallel. That is what a trapezoid is. So you would say yes. Only one set of if we did Ka and Et first and you got that the slopes are the same, you still have to find the slopes of these two sides. Okay? Because just because these two are the same does not automatically mean it's a trapezoid. You have to show that the other two aren't the same. Okay? So you still just have to find the slopes of all four sides. Questions over there?
All right. Let's go on a little bit to the next one. Again, trapezoids are pretty easy. Again, a lot of you, what she was saying is you can look at it and say, all right, which ones are probably going to be parallel? You can kind of guess what they are. But you do have to show this because there are cases where it's very close and it could be a different shape. This could be a parallelogram. So you have to determine that it is not a parallelogram. In fact, it's a trapezoid or anything at all. So this next one here, we're going to prove that quadrilateral milk with the vertices right there is an isosceles trapezoid. Before we get going on this, what do you think it means to be an isosceles trapezoid? What's different between a trapezoid and isosceles trapezoid? You know another shape that has isosceles in its name. What's that mean to be that other shape? Shane? Two sides are equal. Yeah, the legs of it are equal, just like in an isosceles trapezoid. We have two sides that were congruent. That made it isosceles. So the same thing happens with trapezoid here. If it's an isosceles trapezoid, the legs, either side, will be the same. All right, well, first thing first, just like we always do, we graph it out. Yeah, you guys graph it out. I mean, it's easy. We'd be amazed how many people turn in tests and quizzes, and there's nothing on the graph. Everybody knows how to do this. All right, M, 1, 3. I is negative 1, 1. L is negative 1, negative 2. K is 4, 3, 4, 3. And we're going to go ahead. All right, so there it is. Well, just like before, we have to prove that this is a trapezoid. So we're going to have to find the slopes of every side. Yes, every side. I realize that two up here look like they might be parallel. We'll probably start with this first. It doesn't matter, but we have to do all four sides. So, what side would you guys like to find first? It doesn't matter. Who'd like to pick one? Why not? What do you say, IL? IL. Let's find IL. Sounds like a good one. You guys like reading left to right? Let's go for it. All right, IL. So how do I, doing slope, how do I get from I to L? Where do I have to go? Up or down? What do I do? I have to go down. So I'm going down. That means I'm going negative. How far down do I go? Let's count. 1, 2, 3. How far over do I go? What do you say, Derek? 0. Yeah, you don't go over 0. So at negative 3 over 0. What happens with this one? What do we call this type of slope? Undefined. Yeah, it doesn't have a slope. It's going straight up. So this is undefined. So undefined there. All right, cool. Next thing we're going to do is we're going to look at the side that is opposite. So Cindy said IL. What side is opposite IL? MK. Okay. Mr. Mackey right there. MK. All right, what are the directions? How do I get from M to K? How high up do I go? Or down? Do I go up or down any? Going from M to K? No, so we call that a 0. How far over do I go? 1, 2, 3, yeah, 3. And we call this a no slope, or 0. You guys can look at these things and determine what's going on with that. We have something that is created based off these lines. We don't even know that. But are these two the same? Are the slopes the same here? No, they're not. So we got to keep going, figure out what ones are, if any at all. So next one, let's do I'm. I am. Instant message. You guys use Instant Messenger? Have you guys heard of this? You know this? Okay, you got one person know what Instant Messenger is. Anyone else? Instant Messenger. I am. You ever I am somebody?
Oh, like direct message?
No. I am. You have no idea, do you? You guys live in the past. All right, some of you know what it is. Back in the day, before text phones were readily available, people used Instant Messenger on AOL. You guys probably don't know what AOL is either. But it was a thing how we communicate to people. We didn't have cell phones, we didn't text, we called if need be. That's how you communicate with somebody. Crazy, huh? No, you don't. What's it stand for?
Oh, I don't know what it stands for.
Oh.
Like a mail thing. Like an email, because my mom still has AOL.
She has her emails, AOL, probably because
She
she was
can't
first user.
change it because so many people email her.
You gotta have it, yeah. AOL, it was America Online. It was like the first way to access the internet.
She said she used to have to pay for it.
Oh yeah, crazy. Now the internet's free.
Back then, the internet, like having internet came on like discs that lasted like so many hours.
That was the AOL. You had to upload a disk.
Dial up.
You had to dial up. The computer was like screaming at you to get on the internet, and then your phone. You couldn't use your phone while you were on the internet. Oh man, it's awesome. Awesome. Oh, that's AOL. You got mail. All right, here we go. I am is the one that is where we're going to talk next. How do I go from I to M? What do I need to do? Up. Like I said, up 2, 1, 2 over 2. Up 2 over 2. Up 2 over 2. What's going to happen to that? 2 over 2 becomes a 1. All right, cool. Still nothing yet. I've undefined. I have a 0. I've got a 1. That's not going to help me out. Well, we've got one last side that we have to check, and that's LK. LK. Okay,
Was it called dial-up because it just said sort of like a, not exactly that, but
You literally dialed. That's what it made a phone call. So your internet came through.
That's what I was. I thought.
2, 3, 4, 5. You have to go up 5 for L. How far over do you go? 1, 2, 3, 4, 5. And 5 over 5 is also 1. So do I have 2 pairs, or do I have 1 pair of sides that are parallel? Yeah. Do I have 1 side that's not parallel? Yes. So I can now say, yes, it's trapped. Star Wars fans out here? Star Wars fans, you got it? It's trapped. Admiral Akbar. He's like a tadpole. You guys know what Admiral Akbar? Alright. Yes, it's a trap. And I know it's because I have 1 pair of sides, opposite sides, that are parallel. 1 pair of opposite sides are parallel. It's a trapezoid. Now, is it isosceles? I have to go to the next step. Isn't isosceles trapezoid? You told me isosceles means that 2 sides have to be the same. The sides that are not the parallel sides. So I have to look at IL and MK. These 2 right here, the red and the green. What's nice about these 2 though? They are perpendicular. That means perpendicular. Not only that, they're perpendicular. I agree. What's nice about it as far as this graph up here? They're on the line. We can easily count how long they are. So we're going to figure out how long IL is, the distance of it, and MK. Sometimes it's not as nice as that, and you're going to have to do Pythagorean theorem. If it's slanted or curved or they're not straight lines, we just do Pythagorean theorem. Remember, to find the distance or how long something is, you have to use the Pythagorean theorem. But these are nice on lines, so we can really easily count what they are. So look at IL. What's the distance from I to L? 1, 2, 3. All right, that's 3. What's the distance from MK? It is also 3. So do I have, are the legs congruent? Are these pieces congruent? Yes. So I can now say that, yes, an iso trap. And I say legs are congruent. Those sides are holding up the bases. They're called legs. So the legs are congruent. Questions on iso traps. Traps are pretty easy. You guys ready for the next section? All right, nobody's sitting down. That's not good. Okay, listen. Oh, let me pause this. I know.